Excuse the mess again. That's how it is in this place. Okay, so I got 4 coils. Alright, and this is a pickup coil and output coil. 4 coils, I got them rotating. Okay, in a new way, a different configuration. Just getting some data here. The yellow is the output. The blue is the input. So the blue is measuring one phase, just for a comparison to see what phase the output coil is on. The output coil has an 8 ohm resistive load on it. Okay, obviously the output's real low. I'll explain my problems in a minute. Anyway, the yellow is the output phase. The blue is the input phase. The blue's not moving. Now, I'm going to move this coil around like last video. Watch the output phase. Now it's in phase. 180 degrees out of phase. And when I move it back to here, it's 90 degrees out of phase. I'm going to move it over here. In phase. And move it over here. At 270 degrees. You see how? Going like this. And you see how the phase relationship to the input is changing. So this is rotating, but of course the area in between isn't as strong as the poles. Maybe if they overlap or some other configuration you could get that smooth, but I don't know if it's needed at the moment, because you have this, and at the next pole you have this, which is a hair off. Next pole you have this. Next pole you have this. But again, I wasn't perfectly lined up either. I was just kind of sliding them. Anyway, as you see, the field is rotating because we have a shifting phase when you move this coil. Now, I could show with compasses or magnetic iron or something like that to show it's rotating, but in my opinion, those are kind of inconclusive. If you got the scope and if you can make the phase shift as comparing to a single phase that's solid, you know it's rotating, and that sine wave stays looking like a sine wave, like not all choppy. Of course, I got low points when I'm in between coil. It's not receiving as much flux as it is here. Okay, so anyway, I got rotation in several different ways. This is just another way because I'm trying to work out the back EMF problem. So currently when it's rotating, when you raise the frequency, the output starts going up, but then the input keeps going down, which is fighting against me. I can't let that input go down. This is running off 2 supplies. Okay, because I'm isolated 2 phases in here connected together. But the isolation in this method is important. I was hoping this would do something advantageous to my back EMF issues, but unfortunately it's still experiencing that, because on a regular rotor of an alternator, okay, you have a coil. Let me get a coil. Here we go. You have a coil that's being powered by a battery with from the battery, so it's direct current. And as the coil rotates, right, the direct current is still always in the same direction. So it's not shrinking and growing and shrinking and going and switching directions like I'm doing here. Instead, it's always going in the same direction as it rotates. Therefore, back EMF isn't a problem in a generator, because you're not growing and shrinking and collapsing a field. It's always flowing in the same direction, and you're rotating the coil itself. Now, to mimic this without the rotation means you have to switch directions in these coils, because this one needs to be north and that's south, and then you need to switch and that one needs to be south. So it goes north, Then this goes to north when this one goes to 0. Then this goes to north when this one goes to 0 while that one's south. And this goes to north while that one's 0 and that one's south. And it continually rotates in that fashion. But the back EMF has to be handled, or else you could keep putting power in and raising the frequency, and your power in keeps going down, so you're not getting the gain. Okay, now I have a lot more to show about how I connect them. If I connect them like this, what happens and whatnot, and that all may be discussed later, but I'm still experimenting. Now, in a regular transformer, how when the secondaries are connected, the back EMF stops, and it stops sending it back to the positive. It stops impeding you. Then the impedance gets low, and it could draw current, right? So I'm thinking there's a possibility if I build this out right, not big spaces, and it needs cores and a better configuration. When it gets loaded by the secondary, I'm hoping it would eliminate that back EMF. Now, the interesting thing, in certain configurations, you notice when you put a coil between these two, one supply raises input and one lowers input. So the total input stays the same because one lowers and one raises. And if you move it to the next place, it'll do the opposite. The other one will raise and one will lower. So there's a balancing act that happens with magnetic rotation, where it doesn't take any more input. Whatever you're taking out of the circuit or out from induction, right, will pass to one, but then the other supply will draw less to compensate for what you took out. So it's quite an interesting relationship that's going on here. Anyway, I think next, stay tuned. Subscribe and join the forum in the description, because next I'm going to take 4 transformers instead of coils and do this exact same hookup on transformers. So each transformer has a secondary enclosed in laminations, a full core, and see if that takes care of the back EMF problem and if it still rotates like I want it to. So that's what I got right now. Join the forum in the link in the description, and that will bring you to the place where more information is discussed. And stay tuned.